My name is Mr. Young. I'm Head of Physics at Hymers College. We study the AQA Examination Board specification. Within that, there is an optional topic at the end of the year. What most people often ask is what that module is. So we study turning points in physics. The reason that we chose that particular module is that it presents the key discoveries that have been made in the study of physics over the last few hundred years. So included in that is things like the wave-particle duality of photons, the special relativity, Einstein's theory, and the link between mass and energy using Einstein's special equation of E = mc squared. What we need to get onto an A-level physics course, we need good GCSE grades across the board, but specifically in science and maths. We would really expect people to have grades 7 and above at GCSE in order to progress onto the study of A-level. What people often think about and often ask is whether or not they need A-level Maths to be able to study A-level Physics. Students do not need to be studying A-level Maths to access the A-level Physics course. We will help students with the mathematical skills through additional materials and support modules that we will give to those students who are not studying A-level Mathematics. Modules within the course that we study, so we build on everything that we've already studied at GCSE Physics, including mechanics, projectile motion, lenses, ray diagrams. But we build on that and we take it to a deeper level of study. Where people go on to university after studying A-level Physics is many very different courses. So we've had students go on to study economics, to study engineering, many of the disciplines in engineering, so things like civil engineering, mechanical engineering, electrical engineering, and chemical engineering. So it's not just a course that aims to progress people onto the study of physics at university, because we actually get not that many people go on to study straight physics at university. It's one of the key requirements for the entry into an engineering course at university. One of the key transferable skills that is used in economics and business, that why they like the study of physics, is the idea of this modelling, understanding numbers, understanding how variables impact upon a bigger model within a system. So they use it for modelling financial systems, bank systems. So that's a key skill that we use quite extensively, especially as we go into year 13 physics. So we'll give students extensive set of resources, so they'll get a number of textbooks at the beginning of each year, beginning of year 12 and year 13, which we expect students to work with, to study on. I publish what's called a physics bulletin every 2 weeks, and in that physics bulletin is an outline of what students are expected to complete during that 2 weeks of study. Also, in addition to that, to ensure that we understand the progress that students are making, students will sit a short test every 2 weeks on material they've most recently studied. So we start with a couple of tests on GCSE physics material, just to make sure that they are confident and understand what they studied in years 10 and 11. And then we progress on to assessing the material that they've studied at the beginning of year 12, and as we progress through the course, those assessments allow us to have a good understanding of the progress that students are making within the course, so that we can target very specific intervention to those students that require it. At the end of the course, at the end of the 2 years, students will sit 3 examinations. Paper 1, which is based on the material that the students have studied in year 12, Paper 2, which is based on the material that they've studied in year 13, and Paper 3, which is the practical paper plus the turning points module. Okay, so in terms of the practical skills that's required, practical assessment, practical examination, there is no physical practical examination. However, the Paper 3 has questions based on experiments that they've completed during the course of the 2 years, and those experiments can appear in those questions, and students are expected to describe experiments, explain experiments, analyse experimental data, and apply mathematical models to the numerical data in order to derive a physical quantity or a physical constant from the data. Then the optional module, the turning points in physics, which is the module that we get students to study, covers the things like special relativity, Einstein's theory, the wave-particle duality of photons, key discoveries and key experiments that have been undertaken in the last 200 to 300 years of the study of physics, looking at some of the more famous physicists that have occurred over the last few hundred years. So I hope I've given you a good insight into the study of A-level physics, and hopefully see you in September.